meters long and has a mass of 4.3 grams. From the bridge to the support post is 56 centimeters, and the string is under a tension of 517 newtons. What are the frequencies of the fundamental and first two overtones? Fundamental frequency? Don't know. First overtone? Don't know. Second overtone? Don't know. Now I'm going to list our given information. Although the string is said to be 91 centimeters. The problem tells us that our L is 56 centimeters. So that it is what we will use for our length, which is 0.56 meters. Of the given string is 4.3 grams. So our mass is 0.0043 kilograms. That's 1 0. No, 0.0043 kilograms. And lastly, our tension force is equal to 517 newtons.
Okay, now that we have all of our givens listed, we can now analyze them and see which formulas we need to use to find out the frequency that we need. So I'm going to write my name so we know who is working at a given time. So we have length is 0.56, we have the mass, and then we have force. So looking that we need frequency, we can tell that frequency formula, the most basic formula that it's in, is velocity equals frequency times lambda, which is wavelength. And when we rearrange this formula, you get frequency equals v over lambda. Now, when you look at this problem, you notice that you don't directly have the speed nor the wavelength. So to find this, we use another equation, which is V equals the square root of the force tension over mu. Now, mu is a term that means the mass over length. So when we have mass, length, and force, we get V equals square root of 517 over 0.0043 over 0.56. And when we calculate this, we get 259. Oh dear, I'm going to erase this. 259.48 as our value. And now my partner will continue this and to calculate the frequency, and I will write his name for continuity. These two, by the way.
Okay, so I'm Kyle Williams, and I'm going to be walking you through the conclusion of this problem. So, earlier, as Dakota stated, our frequency is going to be equal to the velocity of our wave divided by the wavelength. So, we know what our velocity is, this number right here that Dakota found for us. But the problem is we don't know what lambda is. Now, there is a physics formula that states that lambda is equal to 2L over n, where L is the length of the object that we're trying to find the wavelength of, and N is the number of harmonics. So, if we take this formula and we put it right into the frequency formula that we have, we get frequency equals the velocity of the wave times the number of harmonics divided by 2 times the length of the object. So, for our first harmonic, you're going to get F sub 1 equals 259.48 times 1 all over 2 times 0.56, which is our length. And that's going to equal 231.678. Now, for our second harmonic, we're going to have F sub 2 equals 259.48 times 2 over 2 times 0.56 equals 463.357. And now, for our third and final harmonic, we're going to have F sub 3 equals 259.48 times 3 over 2 times 0.56 equals 695.036. And that's the solution to our problem. Thank you for watching.